Welcome to Crying Out Cloud, the podcast that will make you laugh, cry, and reconsider all your cloud security fears. I'm Eden from the CTO team at Wiz, and I'm here with my amazing co-host, Amitai,
Howdy.
from the threat research team. And today we have a crazy story to get into, and we brought on the man behind this story, which happens to be one of the biggest news stories in the past month in the world of cloud security. Welcome, Hillai Ben-Sasson, who is
Hello. Thank you for having me.
What'd you say?
Thank you for having me.
We're excited. Hillai is a senior security researcher at Wiz and one of our favorite people at Wiz, so it's fun that we get to have him on. So let's jump into this. The research team found Microsoft's AI team, while publishing a bucket of open source training data on GitHub, accidentally exposed 38 terabytes of private data, which wasn't limited to employee workstations, keys for a bunch of stuff, Teams messages. What did I miss? What's the scope of what you guys found?
Yeah, it was actually a pretty crazy finding. We were just looking for, this is part of like a bigger project that we're doing about like cloud exposures on the internet. We were scanning the internet to find any sort of misconfigured, exposed, or overly permissive cloud resources. And we were looking at a feature called SAS tokens in Azure, which we thought was quite dangerous. We were looking for anything that was misconfigured SAS tokens. And then we found this. It was actually on a public GitHub repository under Microsoft's organization. And this link was supposed to host like open source AI models. But in reality, it actually hosted those AI models and also 38 terabytes of extra data, employee computer backups with their personal passwords and their private keys and their Microsoft Teams messages, like over 30,000 Microsoft Teams messages, which are internal to Microsoft. Just crazy amount of exposed data. And also because one singular misconfigured link, which is pretty crazy how big of an impact one mistake can have in the cloud.
And none of this data was meant to be there, right? Like it was only supposed to be the AI training data.
Yeah. Only thing that was supposed to be exposed was a couple of like models, like models for image recognition. Those were like a couple of megabytes of data. But in addition to that, this link it granted access to this and also to everything else that was in the same storage account, which was the 38 extra terabytes of data that wasn't supposed to be exposed.
That seems like a bit of oversharing on Microsoft's side.
TMI, as they say.
Yeah.
This story is crazy, but like the larger significance of this for Microsoft and for data that's being stored, can you kind of like talk about what this means in a greater sense?
Yeah, this is actually like an example of some of the dangers that AI research in particular is more prone to, because in AI, like a core part of working in research and development of AI is sharing a lot of data, because you work with like tons of external data and internal data in order to train your AI models. That's like the most fundamental part of doing AI research. And when you do that, when you have like terabytes of data that you have to share in order to collaborate with your peers, then it's much easier to make those kind of mistakes, right? Because sometimes you don't necessarily have the security knowledge in order to do these things properly. And when mistakes are easy to make, in the cloud, sometimes they are easy to make because the cloud is easy to work with, then overexposure is like a big risk when dealing with these sorts of research projects in AI.
So basically, you're like a data scientist who just wants to share their work or collaborate with other people, and you think, okay, I'll use Azure storage bucket to put my stuff out there, and I'll mix that with GitHub. But it's actually a lot more complex than you might think, and it's too easy to make mistakes.
Yeah, absolutely. Like in the cloud, because everything is so agile and so easy to work with, then just like you can create like an entire network worth of computers in a single click of a button, which you couldn't do in the old world, you can also expose all those computers to the internet, and it will also be one click of a button, and you can expose your entire storage account, and it will also be as easy as clicking a button. Because working with the cloud is so easy, then making mistakes is also much easier to do than like on-premise environments.
It's also interesting because it wasn't just exposed and like readable, meaning it could have been stolen. It was also writable, this data, right? Which meant you like could actually put malware in there.
Yeah, this token was like it was like the most permissive sort of SAS token that you can create, because not only was the scope of access was the widest that you can do, it was like the entire account, but also the level of permissions. Those permissions could have been like read only to the entire account, but those were like full control permissions. You could read, you could write, you could delete. And the crazy thing is, those models, the way that they were shared, it's a file called like .ckpt, like checkpoint, and it's an AI file that is that you can inject malware into. It's serialized using something called a pickle in Python, which means you can create, like by design, you can create an AI model that's malicious. And when someone downloads that model and loads that model into their code, you can run your own arbitrary code using the same mechanism. So I could have like changed, or anyone else could have used those permissions to change the models. And anyone that goes into that GitHub repository thinking, this is a Microsoft GitHub repository, I want to work on the same models that this project has published, could have downloaded those models, and I could have ran my own code on them, which is like a big supply chain risks when we're working with these kind of dangerous files.
But it's not just like data poisoning in the traditional sense of making the model make mistakes, for example, or directing the model to give certain answers that are advantageous to a threat actor. It's actually like if someone used this model, they would literally get infected.
Yeah, it's arbitrary code execution. It's not even, it doesn't have to be limited to AI only. You can literally run your custom malware using this sort of file. It's really easy to do, and it's a danger that's like well known in the AI world.
So why do people keep using this format? Like, why are there other alternatives?
That's a good question. I've actually read a little bit on this when looking at this these sort of files. There is like a safe alternative. It's these files belong to a library called
Playing pickleball.
What?
Just kidding. I said it's playing pickleball.
Playing pickleball with your life. Yeah.
Someone on like comments to the article wrote pickle files are cringe. So that's like a good comment to make. Because there is like a safe alternative. There's a file called safe tensor, which is like a completely different file format. But from my understanding, the pickle files are quicker to work with. They're more efficient in their compression and decompression. So people will prefer working with them for speed. And the safe alternative is apparently slower. That's what some people are claiming online. So there are safe alternatives, but in this case, they use the unsafe one, which
So
is
it's a trade-off between like efficiency and comfort as opposed to
efficiency versus security.
Cool. One of the other things that is interesting is understanding, and you can explain this to everyone listening. There are 3 types of SAS tokens. And at the end of the day, this whole thing comes down to some tokens that were being used. And so the 3 SAS tokens are account SAS, service SAS, and user delegation SAS. Which one here is the bad one? And how do you know if you're using it?
The most popular one we found, by the way, and also the one that Microsoft used, is the one called account SAS, which is basically, it means it's called account SAS because it's like it can give permissions in the scope of the entire account and not something smaller than that. And this is the sort of SAS tokens that we advocate against using. We think it's unsafe to use account SAS when sharing files externally, because it's the entire process of creating this token is quite dangerous, because it's created offline Azure does not know when a SAS token is created. So you can't like track all of your account SAS tokens in the same place. If I'm like I have my own company, I want to see.
Scary.
Yeah, it really is scary, because if I want to see all the SAS tokens that my employees in my company are creating, I have no way of doing that with account SAS. Anyone can create their own tokens and share them on the GitHub or on WhatsApp or whatever they would like, and I have no real way of knowing when they did that because it's all completely offline. But what we recommend is using, if you want to use SAS, to use any safeguards that you have with the other types of SAS tokens. You can read in our blog if you want to find out more. But basically, you have something called a stored access policy, which is a way of doing the SAS token in a way that's not 100% offline. It's somewhat managed in Azure, so you can view like all of your SAS policies in one place, which is more transparent. And you also have a user delegation SAS, which is a SAS token that uses authentication with Azure Active Directory. So all the actions that you do with this token are authenticated. You know who are the people that are using it, who are the people that are creating it, and it's also limited to 7 days only. So unlike the other type, which can be
1 week of fun and you're done.
Yep. And
that was for you
in this token, it expired in 2051. It had like a 50-year expiry.
I wonder if SAS tokens will still even be around then. Like
if the cloud is going to be around, if humanity is going to be around, if in 2051.
It's too existential. Let's stick to SAS tokens.
and how long would this have been available if you hadn't found it? Like, could this have stayed open for until 2050?
Yeah, if someone hadn't like taken the active action of disabling that token, which is also not very easy to do, by the way, with account SAS tokens, if someone hadn't disabled that manually, that token would have continued living until 2051, which is crazy because no one had any way of knowing that this token existed. If I was like an admin on Microsoft's Azure tenant, I couldn't have just looked at all my SAS tokens to see, wait, there's one that's with a lot of permissions and it expires in 50 years. I had no real way of doing that. It's only because we found it that they disabled it manually. It's just pretty crazy, honestly.
So if you were Microsoft, like what would you be doing right now? Would you be scanning your entire infrastructure for SAS tokens to make sure that this can never happen again?
So actually, one of the things that Microsoft changed because of our report was because this was on GitHub, and GitHub actually has tools for secret scanning that help you, scan your own repositories to see if I maybe left some passwords or private keys or anything. They added detection to detect overly permissive SAS tokens, which wasn't there before and could have maybe caught this. So now they have it on GitHub. When you use GitHub secret scanning, it will now show overly permissive SAS tokens in your repositories, which is a great start. But honestly, this is a difficult problem to tackle because you have no way of knowing what all your SAS tokens are. You would have to scan externally, and it will be like an opportunistic way of forking. So it's just a pretty dangerous mechanism. You have to really know what you're doing if you're using SAS tokens.
But it sounds like to the positive, Microsoft was able to like react quite swiftly and like implement really good guardrails after this.
Yeah, Microsoft definitely reacted very quickly. After 2 days after our report, they already invalidated that token. And they did like an internal investigation, like very comprehensive investigation to make sure that this exposed bucket did not affect any customer data or internal Microsoft pipelines. And they say that the investigation was complete and no harm was done, which is always good to hear.
We love it. We love a no harm done situation.
It's important.
And I also just think it's really like cool to be able to see the like collaboration between you and the Wiz research team and Microsoft and the ability to jump on these situations. So that's also quite interesting.
Yeah, they're a great partner, honestly. I really like working with the MSRC. They're always very quick to respond and take our reports very seriously. So shout out to MSRC.
Awesome. Okay, so let's say you're listening to this, you use Microsoft, you're in Azure, and you're like, what should I do anything? Like, is there something that cloud customers should be expected to look at, take action?
Yeah, absolutely. I would recommend anyone that uses Azure storage in their like production services to try to check if anyone in the organization is using this mechanism, if anyone uses SAS tokens. And I mean, if you don't, then there's an easy answer, right? You can just disable SAS tokens. You can do that in various ways that we detail in our blog and the MSRC blog. You can disable SAS tokens completely. If you can avoid it, then maybe you should. And if you do use it, I would recommend taking a look at what exactly who in your organization is using it, and can they maybe switch from account SAS tokens to either user delegated SAS tokens or stored access policies, and some way that will be more manageable, some way that will grant you more visibility about the tokens and more control over them. And yeah, that's basically what I would do if I was using Azure, and specifically Azure storage right now.
And first and foremost, don't panic.
Never panic.
Stay chill, all good. I have a question before we wrap this up, but I have a question about like Big Bang, which obviously came also from your team in this incident, and old school I'm bringing back. And I think like, first of all, it's amazing that your team continues to do all this like really fascinating research and bring all this to the surface. But are these similar or different? Like, what would you say are kind of the common threads between the two? Or are they just completely separate occurrences?
That's a good question, honestly, because there is common ground between these two researchers, and meaning that both of them are essentially exposed cloud resources, right? Because this resource was a SAS token in an Azure storage account, and this resource was an Azure Active Directory app. But both of them were essentially cloud resources in Azure that were exposed for a very long period of time, actually, in both of them. And because of the services maybe limitations and how well people know their cloud services before they use them, they basically stayed hidden. No one really knew that they existed. Hopefully, no one knew that they existed. And when you try to scan the internet to try to find these things, you actually find a lot more data than you expect. Besides, in that research, in the Big Bang research, besides the Bing app, we actually found hundreds of other apps from hundreds of different organizations other than Microsoft. And in the SAS tokens as well, there's still, hundreds and probably thousands of SAS tokens that are scattered online, and maybe no one even knows they exist. And that's makes it important to scan your environments, sometimes internally, sometimes externally. Try and find these findings. They're actually really similar in that regard.
And in both cases, it's Microsoft basically making a mistake within their own services, meaning that if Microsoft can make this mistake, then I think we have to assume that many of their customers are making the same mistake as well.
Absolutely. The fact that, Microsoft was, the case study in both of these researchers doesn't mean that it's like a Microsoft specific problem, because they use Azure, and also, a big percentage of the internet uses the same services in Azure as well. And when these mistakes are easy to make, then, maybe Microsoft will do these mistakes as well. But they're just, an example. Anyone could have made those mistakes. They're easy to make. And it's important to stay on top of your cloud environment to make sure that you don't make those similar mistakes.
And I hope cloud service providers get better at making these mistakes harder to make.
Absolutely. Adding, all these guardrails and policies is important, and it's actually a really big part of what we do, because when you find a big finding like this, then it sheds light on like a problem, an underlying problem. And hopefully adding stuff like, the GitHub secret scanner, or in the Bing case, lots of Azure Active Directory changes that we helped, our reports helped make these services a little bit more secure, hopefully, for other users other than Microsoft.
Yeah, like it seems like in this case, like when you share an S3 bucket, you get a big warning saying, check out what you're going to do and make sure that this is really what you want to do. I think it makes sense that in SAS tokens, there might be a similar warning, right?
Oh, absolutely. We think that when using an account SAS token, the user should be really aware of what they're doing and the dangers in doing these sort of things. If it's a long expiry time or very permissive permissions, a user should be able to do that maybe, but he should be also aware that it's a dangerous action.
Proceed with caution.
Yeah, he should be able. He should need to click like 5 times before.
Big red buttons.
Okay. So, in summary, I'm like distracted by looking at Otai's cat, who is so cute in the
It's the
background.
most distracting cat. I can't stop
Absolutely a
looking at it.
wonderful addition to the pod. Invite him back. Please do.
He's just very relaxed because he knows that his cloud environment doesn't have SAS tokens enabled, so he knows that his users aren't making these kind of mistakes. So he knows he can
He's
relax
leading
today.
by example.
Yeah.
Amazing. Hillai, thank you for joining us.
Thank you for having me.
Thank you for doing this cool work so we can all learn about it and bring that visibility out there in the world.
And thank you for making the cloud safer for everybody.
We're trying.
Amazing. Well, that's all for this episode of Crying Out Cloud, presented by the cloud security company Wiz. And if you enjoyed the show, be sure to subscribe, give us a rating, and remember, unlike your IAM policies, more stars is better. And as always, if your cloud security strategy is making you cry, don't worry. Just cry out cloud. Amazing.